Hi friends, this is Miss Chandler. I hope you're all doing well and staying safe. I have recorded a lesson for us to review potential and kinetic energy. You should have received a handout of guided notes to use during this lesson. Please be sure to pause the video and fill in your notes as needed. At the end of this lesson, you will be able to compare and contrast potential and kinetic energy. So let's talk about what it means to compare. If we're going to compare two things, then we're going to see what these two things have that is in common. What are their alikes? How are they similar? And if we're going to contrast two things, then we're going to look to see how they're different. So what do they have that is not alike? Okay, let's go to the next slide. So let's review what energy is. Energy is the ability to do work. Work means a change in temperature, speed, position, pressure, or form of matter, and is a result of energy applied within a system. Therefore, energy is the ability to use force to move an object over a distance or to cause change in matter. So if you think back and remember what a force is, we know that a force can be either a push or a pull. So if I'm going to push an object across the floor, then I have to exert force, which takes energy to do that. And energy, of course, is the ability to do work. So then I'm doing work in order to push this object across the floor. Okay. Our next slide here, I'm going to turn on my highlighter to help you guys see just a little bit easier. So we have energy, okay? What I would like for you guys to do now is to take out index cards or a blank sheet of notebook paper and follow along with these definitions. They are a review of what we've already done in class. Super simple. There should only be about 4 or 5 definitions for us, okay? So use these definitions and have a sibling or a parent quiz you over these definitions just so that we can keep it fresh in our mind. And also, please don't forget to pause the video as you need to fill in your guided notes. So energy is the ability of a system to do work. Energy is required for changes to happen within a system. Okay, so energy is required for change to happen within a system. As you can see in this picture here, this runner, her body is a system. She has muscles, bones, her skeleton, her skeletal system, all of her systems in her body are working together. They all create a system. So as you can see in this first position, she's moving. She has one foot on the ground and one foot is off the ground. And then the second position, neither of her feet are touching the ground. And then this third position, her back foot is just coming down, okay? So we can tell by the position of her body that she's moving, okay? So she's using energy to do work, which is causing a change to her body as a whole. Our next definition is the law of conservation of energy. And this states that energy is never created or destroyed. It is only changed from one state to another. So with that being said, we know that we can't create energy. We know we can't destroy energy. We know that it can only be changed from one form to another. So that can be radiant energy that is taken in by plants, which is then transformed over to chemical energy. Or when you guys eat plants, that gives your body chemical energy, and then you use that energy and you turn it into mechanical energy when you run during PE. So we know that energy is always changing forms. We can't create it and we cannot destroy it, but it's always just going to change from one type to another. Your next definition is energy transformation. And this is the change of energy from one form to another. So again, energy is constantly changing. It's never created, it's never destroyed, it's just constantly changing. And if you guys remember the different forms of energy, again, we have chemical that can be transformed to thermal energy. So maybe whenever you guys eat your fruits and vegetables, you take in that energy as chemical energy. And then once you start running, you know that your body heats up, you begin to sweat. That energy is then transformed to thermal energy. We have mechanical energy. So in the example given here, we have windmills. We know that the blades on these windmills will start to turn, which is going to be mechanical energy since they're moving. That mechanical energy is then captured and then generated as electrical energy. Let me move my screen so you guys can see all that. The next one that we have is chemical energy. Again, when you guys take in like fruits and vegetables in your food that you eat, and then you go run at recess or PE, then that energy is then transformed to mechanical energy when you begin to move. And then again, we have radiant to chemical. Okay, so potential energy. Potential energy is energy that is stored in a system or an object. So it's energy waiting to be released, energy that it's waiting to come out. The example that I've given you guys is this really huge boulder on top of this cliff. So at the top of this cliff, this boulder has potential energy. It is full of stored energy. It's not moving. It's not coming down this cliff yet. But we know once it does move, then that energy will then be converted to kinetic energy. But at this moment, at the top of this cliff, this boulder only possesses potential energy. Another example is this rubber band. So I know that you guys have all probably taken a rubber band and you've stretched it as far as you can between your fingers. When you take that rubber band and stretch it, then it has potential energy. It's not moving. That energy is stored at that moment. And whenever we take this rubber band and stretch it, we're going to call that elastic potential energy. Another example would be the guy riding the bike on top of this hill. So at the top of the hill at this moment, he's not moving. So he again has potential energy. And then we know as he comes down this hill, then he begins to move. And his potential energy will then be converted over to kinetic energy. And then in this picture, we have a woman that's holding this bow and arrow. She has the strings pulled back on it. She has not released her arrow yet. So at this moment, that bow only possesses potential energy. Once she lets go of that bow and that arrow begins to move, then that energy will then be transformed to kinetic energy. And your definition for kinetic energy, which we know to be energy of motion. You guys know that mechanical energy is energy of movement as well. So a lot of times we're going to refer to our kinetic energy again as mechanical kinetic energy. That's a big one that we're going to use and see a lot. Here's another example. This girl has let go of the ball, so the ball is now in motion. It is moving. The ball is falling down. So that energy at the top, it was potential, and then once she released the ball, it was transformed to kinetic energy. And then again, we have another bow and arrow for you. Once the bow was released and the arrow was released, that arrow now has kinetic energy. So in the starting position, when the string was pulled back, the arrow had potential, and now that the string was released, the arrow was released, and now it has kinetic energy. These bowling pins. So when these pins were setting up, waiting on the ball to arrive, they possessed potential energy. But now that the ball has collided with those pins, these pins are now moving, they're now in motion, therefore they have kinetic energy. Here's another example for you. So here is an example of a student or a small child that is on a swing. So in position A, at this moment right here, the swing is not moving. It is paused for just a brief moment. So we know that that swing has potential energy at this moment. But once he begins to swing forward again, between position A and B, there will be kinetic energy. So that potential energy will be transformed to kinetic energy. And then once the child stops for a brief moment at position B, then we know that again, that kinetic energy was transformed back to potential energy. And then he's going to lunge forward, and right here between B and C, we know that that's going to be kinetic energy. And then at position C, he's going to be stopped for just a moment, and we know that that kinetic energy will be transformed back to potential energy for just a moment. In this scenario, we have the bowling ball again. So this bowling ball, as it's rolling down this lane, this alley lane at a bowling alley, that ball is moving. It is in motion. It has kinetic energy. These pins are not moving. They're standing still. They're upright and they're uniform. They're not moving whatsoever. So we know that they have potential energy. They have the potential to move. They have the energy in them, but at this moment they're not moving. But once this ball collides with the pins, then that energy will be transformed from potential to kinetic. They might not move far, but we do know that they will possess some motion because they are going to move. They would not move if they didn't have energy and they were not in motion. Alright guys, so you should also hopefully have received a copy of your Venn diagram in your choice boards. So what I'm going to leave you guys with is this Venn diagram. I want you guys to compare and to contrast potential and kinetic energy. Just put a couple things right here on this left column. Just a couple things that you do know about potential energy. It doesn't have to be long. It doesn't have to be elaborate. Just maybe 2 things that you know about potential energy. And then on the right column, I want you guys to tell me a couple of things that you know about kinetic energy. And then in the middle, you guys are going to tell me 1 or 2 things that both of those energies have in common. So I hope that you guys enjoyed our lesson today. Thanks for participating. I miss you guys, and I hope to see you all very soon.